Hey everyone, so here is the rest of the final review. I know that the numbers don't match up, but these are the same word problems that are at the end of your final review sheet. Okay, so on 91, which is probably like, I don't know, 120 on your review sheet or something, I don't remember. So it's at a point on the ground 50 meters from the foot of a tree. The angle of elevation to the top of the tree is 48. Find the height of the tree. So if this is your tree right here, it's a blue tree, okay? And it says that you want to find the height of the tree. So I'm looking for the height of the tree. So I need to find this H, right? And it says 50 meters from the foot of the tree. So 50 meters, this is going to be your 50. And it says the angle of elevation to the top of the tree is 48. So the angle of elevation is going to be looking up to the top of the tree. So that's going to be this guy right there. It doesn't even look like a triangle. So this is 48 degrees, okay? And you can assume that this is a 90 unless I tell you that the tree is lopsided. Okay, so it says find the height of the tree. So what I have here, I can use SOHCAHTOA since it's a 90. I have an angle, I have its opposite side, and I have its adjacent side. So opposite over adjacent is tangent. So I can do tangent of 48 is H over 50. And then multiplying both sides by 50, I'm going to get 50 tangent of 48 equals H. And then plugging that into your calculator, 50 tangent 48, I get that the height of the tree is 55, oops, not 5 point, sorry, 55.53 or something like that. Does it say what it is? Feet, I guess. Okay. All right, number 92, from the top of a lighthouse. So this time we have a lighthouse. So here's your little lighthouse, right? I do not know how to draw a lighthouse, but whatever. That's 190 feet high. So this is 190 feet high. The angle of depression of the boat out to sea is 34 degrees. So you're looking out at a boat with an angle of depression. So if you're looking straight out like this, your angle of depression is going to be this. So this is going to be your 34 degrees. So when you're looking out at a boat somewhere over here, okay? And then the question is, find the distance from the boat to the foot of the lighthouse. So you're looking for this X, okay? So I need a couple more angles here. I can find this angle right here by just subtracting, because these guys together make 90. So I can find this angle by just going 90 minus 34. Okay, and 90 minus 34 is 56 degrees. So this guy right here is 56 degrees. Let me redraw this triangle. There's just too much going on. Okay, so this is a 90, this is 190, this is 56 degrees. And I'm looking for X. Okay. So now how do you do that? Again, because you have a right triangle, you can use SOHCAHTOA. So I have an angle, I have its opposite side, and I have its adjacent side. So I can, again, opposite of adjacent is tangent. So I can do the tangent of 56 equals opposite over adjacent. And then if I multiply by 190 on both sides, I get 190 times the tangent of 56 equals X. And then plugging that in, 190 tangent of 56, and I got that the distance is 281.68. And is it feet? Yes, I believe it's feet. Okay. All right, we did this one in class, but I'll do it again for you guys. So from a certain distance, the angle of elevation to the top of the building is 17 degrees. So from a certain distance, you're looking up at the top of the building, and the angle of elevation, which means looking up, is 17 degrees. Okay, and a point 50 meters closer to the building, so from here, 50 meters closer, you're looking up with an angle of elevation of 31 degrees. This you can assume is a 90. Find the approximate height of the building. Okay, so you guys remember on this problem, if this pops up on your final, you need to find this first. And the way to find that first is to look at this triangle right here. Okay, so I'm kind of taking that triangle out, and then this guy right here is the side that we're looking for. So let's label everything that we have. We know that this is 50. We know this is 17. I need to find another angle here. So this angle right here is just going to be 180 minus 31, which is 149. And then to find this little missing angle, this is just going to be 180 minus 149 minus 17. I believe that was 14, but let me double check. 180 minus 49 minus 17. Minus 1. Yeah, it's 14 degrees. So this guy's 14. Okay, so I can go ahead because it's not a 90, so I can't do SOHCAHTOA, but I can use the law of sines. So I can do the sine of 17 over, I guess we can call this x or whatever. So the sine of 17 over x equals the sine of 14, which is this guy, over its opposite side, which is 50. And then to solve for x, I'm just going to cross multiply. So it's 50 sine 17, and then divide by the sine of 14. Okay, plugging that into my calculator. So you have 50 sine 17 divided by the sine of 14. And for that one, I got that x is around 60.42. So this right here is now 60.42. Now, how does that help me? Is that I can now go into the right triangle. So if I go into the right triangle, here I'll do a different color. I'm going to look at the right triangle. So the hypotenuse we just found was 60.42. That's your 90. This is 31, and I'm looking for h. Now that you have a right triangle, now you can use SOHCAHTOA. So again, you guys, I have an angle, I have an opposite side, and a hypotenuse. Opposite over hypotenuse is sine. So I could do sine of 31 equals opposite over hypotenuse. And then multiplying both sides by 60.42 is going to give me that the height is 60.42 times the sine of 31. Yikes, it's getting really small. So 60.42 times the sine of 31. And I got about that the height is 31.11. Is it feet still? Meters, I guess this one. Okay. All right, Maddie's standing on a cliff looking at a boat, angle of depression of 20. If the cliff is 250 feet, how far is the boat from the base of the cliff? You guys, exactly the same question that we just did on number, I think it was 92. Okay, so you have a cliff, okay? The cliff is 250 feet tall. How far is the boat from the cliff? So I'm looking for this. This is x. And the angle of depression is 20 degrees. Now again, angle of depression, if you're looking straight out, your angle of depression is this. So this is 20 degrees. So that means this guy, since they have to add up to 90, is going to be 90 minus 20, which is 70 degrees. Okay, so because I have a right triangle, I can use SOHCAHTOA again. So I have my angle. I have opposite over adjacent. So I've got tangent again. Remember TOA. So the tangent of 70 equals opposite over adjacent. And then if I multiply both sides by 250, I get 250 tangent of 70 equals x. I'm plugging that in. 250 tangent of 70. I got that it's 686.86 or something like that. And I think we're at feet again. Okay. All right, Violet and Harold are leaving school at the same time. So I see these little coordinates here. So I'm going to make myself a compass. Remember, this is north, south, east, west. Okay, and it says that Violet runs at 15 miles an hour going 20 degrees east of north. Well, this is north. If she's going 20 degrees east of that, that's going to be in the east direction. So this is going to be 20 degrees. So this right here is the direction that Violet is going. I'm just going to label it V. Okay, and then Harold runs at 10 miles an hour going 35 degrees east of south. Where here's south. 35 degrees east of that is going to be a little bit more, maybe like that, 35 degrees east of that. So Harold is running in this direction. Okay, and then the question is, how far apart will it be after 2 hours? So I'm looking for this. I'm looking for this x. Now, you guys, look, this looks like a 90, but this is not 90 degrees. We cannot assume that. A lot of you did that on the test when you took this test a long time ago. Okay, so let's go ahead and take this triangle out of the picture and see what we've got. And sadly, all we have is a triangle. We know nothing. Okay, so maybe I can try to find this angle here. Well, I know that all three of these have to add up to 180. So this little guy here has to be 180 minus 20 minus 35, right? So 180 minus 20 is 160. 160 minus 30 is 130. It's going to be 125 degrees. Okay, now let's get some sides here. You can't just say Violet is 15 and Harold is 10. You got to turn into a distance. So if Violet runs at 15 miles per hour for 2 hours, her distance is going to be 15 times 2, which is 30. So this is 30. And then Harold runs for 10 miles per hour for 2 hours. So his distance is going to be 10 times 2, which is 20. Okay, and now I'm looking for this distance x. Now I'm going to go ahead and give it some labels, A, B, C. So I'm actually looking for a little a. And the reason I did that is so I can use law of cosines a little bit better. Okay, so let's go ahead and do law of cosines. So I'm looking for a little a. So I'm going to use a squared equals b squared plus c squared minus 2bc cosine of a. Now plugging that in, I'll get little a squared equals 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 125. I'm sorry, that got really tiny. Let me make it bigger for you guys so you can see it. Can I make it bigger? It won't get any bigger. There we go. Okay, now I'm going to go ahead and take the square root as well. Okay, so a is going to be, and I'm just going to plug that exactly the way I see it into my calculator. So do the square root button, then I have 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 125. And you guys, I got 44.59. And I think that's in miles. Okay? All right, so that's the Violet and Harold problem. Now, very similar, except we have 2 ships this time, and you guys were almost there. 4 more problems. Okay, so again, I need to draw a little coordinate system here. I wish had left myself a little bit more room, but it's okay. This is north, south, east, and west. And you leave San Francisco at the same time. Let's assume this is San Francisco. One travels 40 degrees west of north. Well, if this is north, 40 degrees west of it is going to be this direction, right? So here's ship number 1. And then it says the other travels 10 degrees west of south. So if this is south, 10 degrees west of that is maybe going to be like a little bit like that. Okay, and then it says, how far apart are they after 4 hours? You guys, exactly the same question as the dog question. Okay, let's take the triangle out of here. So it looks something like this. Okay, again, I need to find this angle here, which is going to be, because all of these add up to 180. So this guy's going to be 180 minus 40 minus 10, which is 130 degrees. Okay, now let's see how far these ships have gone. So one is going at a speed of 20 knots. So if you're going 20 knots for 4 hours, the distance is going to be 20 times 4, which is 80. So that's ship number 1. And then ship number 2 is going 15 knots for 4 hours. So the distance is going to be 15 times 4, which is 60. And then again, if you want to label this A, B, C, you're looking for how far apart they are, so that's B. Okay, again, using the law of cosines, you're going to use B squared equals A squared plus C squared minus 2AC cosine of A. And then just plugging that in, you're going to get little a, which is 60, plus little c, which is 80, minus 2 times 60 times 80 times, oops, I forgot that 0, times the cosine of b, which is 130 degrees. And you guys, I'm going to go ahead and square root that and just plug it in exactly the way that I see it. So you're going to have 60 squared, oops, I forgot the square root. Square root of 60 squared plus 80 squared minus 2 times 60 times 80 times the cosine of 130. And for this one, I got that the distance between the two ships is about 127.16 nautical miles. Okay? All right, 97, two cars leave together from point A, so let's call this point A, and one travels along a straight highway that are an angle of 65 degrees from each other. So you got these two highways that are an angle of 65 degrees from each other. If their speeds are 50 and 60 miles respectively, how far apart will they be after 2 hours? So this guy, if he's going 50 miles per hour for 2 hours, that distance is going to be 50 times 2, which is 100. So this is 100. And then the other guy is going 60 miles per hour for 2 hours. So that distance is going to be 60 times 2, which is 120. And then I'm trying to look for little a. Guys, same question. Oh my gosh, it's like the same question over and over. Law of cosines. So I'm looking for little a this time. So little a squared equals b squared plus c squared minus 2bc cosine of a. Okay, so plugging that in, little a squared is going to be... okay, so I don't have a little b and a little c, but let's just go ahead and label it ABC like that. Is that okay? So little b, that's 120 squared, plus little c is 100 squared, minus 2 times little b, which is 120, times little c, which is 100, times the cosine of 65. And I'm going to go ahead and square root this thing again and plug that in just the way I see it. So you're going to have second square root of 120 squared plus 100 squared minus 2 times 120 times 100 times the cosine of 65. And for this one, I got 119.4 miles. Okay? Okay, number 98. Two observers 200 feet apart are in line with the base of a flagpole. So here's your flagpole, and there's an observer here, and there's an observer here, and they are 200 feet apart. Okay, the measurement of the angle of elevation to the top from one observer is 30 and from the other is 60. So the question is, who's 30 and who's going to be 60? Well, the 60 is the bigger one. If you're standing closer to something, you're going to be looking at something like above you at a bigger angle. So it's got to be this way. And then you guys, how far is the flagpole from each observer? How tall is the flagpole? Hey, I'm not going to do this on the test. I'm just looking for this. Okay, so let's look for H. And you guys, again, exactly the same question as before. I want to find this first using that oblique triangle. So let's look at this oblique triangle that I've got here. I know this is 200. I know this is 30. And then I'm looking for this, right? Okay, so let's get some angles here. If this is 60, 60 plus what is 180? That would be 120. And then this, oh my gosh, it's a isosceles triangle. Do you see that? Okay, so if this is 30 and this is 30, if it's an isosceles triangle, if these angles are the same, that means these guys are the same as well. So that was kind of easy. I didn't need the law of cosines. So this is 200. Now let's look at the right triangle. So here's my right triangle. This is 90. This is my height. I know this is 60, and I just found that this is 200. Because it's a right triangle, I can use SOHCAHTOA. I've got an angle. I've got opposite over hypotenuse, which is sine. So I'm going to go ahead and do sine of 60 is opposite over hypotenuse. So multiplying both of them by 200, 200 sine of 60 is going to be your height. So let's find that. 200 sine of 60. So the height of this flagpole is 173.2 feet. Okay? And then the last one, and you guys, I apologize, these do not really match up to the numbers on the actual test, but this should be 128 on your test. Okay, not on your test, on your review. The measurement of the angle of elevation to the top of a building from the point of the ground is 38. So again, I have a building. I have a point on the ground and I'm looking up at it. This is 38 degrees. From a point 50 feet closer to the building, the measurement of the angle is 45 degrees. You guys, exactly the same question. Okay, what is the height of the building? Hey, look, we've done so many of these. Why don't you try to do it and see if you get the right answer, and then maybe pause the video, okay? And then you can double check. Okay, so I'm going to look at this oblique triangle here. Remember, I'm trying to find this side first, right? So this is 38, this is 50, okay? If I want to find this, this is going to be 180 minus 45, which is 135, okay? And then if I want to find this missing angle here, I just subtract the other two from 180. So 180 minus 135 minus 38, that's going to be a really small angle. It's 7, so cute. Okay, so let's use the law of sines. So I have the sine of 7 over 50 equals the sine of 38 over x. I'm going to call this little guy x. So if I want to cross multiply, it's going to be 50 sine 38 and then divided by the sine of 7. So let's see what that is. 50 sine 38 divided by, oops, I forgot a parenthesis, divided by the sine of 7. And I got 252.59. So this guy is 252.59. And then I'm going to go ahead and pull out that right triangle here. So here's my right triangle. This is 252.59. This is 45. And this is my height. So again, on this one, I can use SOHCAHTOA. I've got an angle, I've got opposite hypotenuse, that means I've got a sine. So sine of 45 is the height over 252.59. Then if I multiply both sides by 252.59, that's going to give me my height. A second, times the sine of 45. And I got that my height is 178.6. Okay, and you guys, I apologize for the misnumbering of this. This should have been 128 on your final review. That makes this count backwards. This is 127, 126, 125. 124, 123, 122, and 121. I believe that was, oh, and then 120. Okay. All right. Well, there it is. And then you guys don't forget period 0 and 5 final are on Tuesday. So that would be tomorrow. And then period 3 final is on Wednesday. Don't forget to bring your final reviews. They're due tomorrow. Okay. Have a good day.